All right, so here's an example. We saw one just like this at the end of class. We didn't do it, but we like looked at it quickly and then went on. Where you'd have to do a little bit of cleaning up before you could jump into this problem. And this is about recognizing that division is like multiplication. It's distributive. We could also recognize that we know how to add and subtract fractions. So rewriting this, I'll go slowly here. We could rewrite this as, come on, child. 3x to the fourth over x minus 2x squared over x plus 1 over x. This is much more efficient than trying to like bring that x and make it a power of x to the negative 1. That's not to say you can't do that. If you did that, you just need to make sure that when you turn that x into an x to the power of to the negative 1, that you are still going to distribute that x to the negative 1 to every term of the numerator. And then you're doing exponent rules, same as we're about to do in the other one. It's just a different way to handle it. You could also, at this point, we're going to learn a product and a quotient rule. You could use any one of those to tackle this problem. So you could use product, quotient, however you want. But the simplest thing to do is just recognize, okay, there's a single term in my denominator. Let me split this up into a bunch of smaller fractions that I can use that sum and difference rule with to make things a little bit easier. So this simplifies to 3x cubed minus 2x plus, and then I can use my little negative exponent to rewrite 1 over x as x to the negative 1. Now we're ready to apply our power rule, keeping those scalar multiples around. We end up with 9x squared minus 2 minus x to the negative 2. Again, if you need to move slower. Like I said, on a test, especially on a quiz, there's nothing wrong with being like, this is 3 times 3x to the 3 minus 1. This is minus 2 times 1x to the 0. And this is plus negative 1 x to the negative 1 minus 1. So you can see all of this happening. In fact, maybe not even the 0, maybe a 1 minus 1. So we can really, really see what's happening there. So, but this is it. We're done. Again, if no one tells you to rewrite exponents as positive, just leave that as it is. Do not go any further. You're done.